Good day. So today we're going to be doing on the LeetCode question 1431, kids with the greatest number of candies. So let's just get into it. So there are n kids with candies. You're given an integer array candies where each candy's I represents the number of candies the ith kid has, and an integer extra candies denoting the number of extra candies that you have. Return a Boolean array result of length n where result I is true if after giving the ith kid all the extra candies they will have the greatest number of candies among all the kids or false otherwise. Note that multiple kids can have the greatest number of candies. So in the example that I give here, for the first one, 2, 3, 5, 1, 3 is your input array. Extra candies equal to 3. And the output would be true, 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 false, true. Reason being, if you were to add 3 to any of the values, to any of the I values in the candies, you would have the value being more than the largest of the candies array before you had to add anything. So adding 3 to 2 would give you 5. We see here that that's true, so we know that this is greater than or equal to as well. So that's 5 plus 3 here would be 6. So that's greater than, plus 5 here, plus 3 here would be 8, greater than, so that'd be true. However, 1 plus 3 is 4, so that would be false. And 3 plus 3 is 6, so true. Yeah, so these examples are kind of just more of the same. So let's just get into the actual solution. So given the input array is an integer array, candies and an extra candies int, the result would be a Boolean array. So basically what the question is asking us is that they want us to find if the current child's candy plus the extra candy is greater or equal to the max candy that all the kids have, the max candy of all the kids. So you have your edge cases, the cases here. So you have candies, candies equal 2, 3, 5, 1, 3, extra candies equal 3. This is just an example, and then you have an edge here where all of them are the same. Not really an edge, but I couldn't really think of any like very strange cases, especially given the constraints. It's pretty restrictive, so not too much to say about that. So the first thing, let's get into the pseudocode. So the first thing we want to do is get the max candy from the array. That's going to be our baseline for comparison. We'll initialize our result array and we'll set I equals 0. Going through here, for I in range length of candies, we want to store the current child's candy plus the extra, so we're just gonna make something to store that. So new amount equal candies I plus the extra candies. So candies I would just be the value of candies in the array at location I plus the extra candies, and we just compare the max candy with the new amount, and if the new amount is more than or equal to the max candy, then we just append true to the array, to the return array. Otherwise we append false. So pretty straightforward. So into the code now. So the maximum value, we get the max, initialize our result. So for I in the range of the length of candies, we just calculate the new amount, which would be the value at location I plus the extra candies, compare it with the maximum value that we found up here, append true or false the array based on if the new amount is greater than or equal to the maximum value. So pretty straightforward question. You just return the array and it should be of the same length because we go through the same amount. In terms of time complexity, it's going to be ON because we have to go through the entire array once. Nothing nested. In terms of the actual space, I believe should be ON as well because we have to return that array. That's going to be of length n, which would be the length of the passed in array. So yeah, all right, thank you.